Okay, let's unpack this. We're doing a deep dive today into a really specific corner of professional AV.
The very high-stakes world of signal compatibility.
Exactly. We're looking at source material on just one device from HDTV Supply, and they're known for, the heavy-duty stuff, modular matrix switchers, AV over IP gear.
Right, and our mission today is to figure out the value in a device that is, physically tiny. We're talking about the tvONE 400-29101,
It's a passive video converter.
a passive converter, but it costs over $400. And the question is why? Why does this tiny piece of hardware, which really just looks like a basic adapter, solve a problem so critical it commands that kind of price?
That is the core question. It looks simple, but its function is, well, it's incredibly specialized. So fundamentally, what problem is this solving for an AV integrator?
Its real job, its true function is as a sync combiner.
Sync combiner.
Right. Think about it. You have these legacy VGA sources.
Yeah.
You still see them in control rooms, simulation setups, and they need to talk to older but very high quality RGB displays. The converter's whole job is to bridge that connection while preserving the original resolution and scan rates. No signal loss.
So if it's just, converting one plug to another, why can't a simple $25 cable do the job? Where's the hidden complexity here?
It all comes down to timing. Standard VGA, the one with the 15-pin connector, it sends its horizontal, the H-sync, and its vertical, the V-sync synchronization signals separately.
Two different signals.
Two different signals.
Yeah.
But many professional RGB displays, especially the ones that use those BNC coaxial connectors, they're expecting all of that timing information to be combined within the signal itself.
And here's where it gets really interesting. This is that engineering nugget, the whole sync on green concept, right?
Absolutely. That's the magic trick.
Yeah.
The tvONE converter passively does that synchronization merge. It takes those two separate signals, H and V sync,
Yep.
and it places both of them right onto the green channel of the output.
The green channel.
Onto the green channel. That's why the output has three BNC connectors, red, green, and blue. But that green channel is now doing double duty. It's carrying color and all the timing data.
I like the analogy from the source material. It's like instead of sending H and V sync as two separate packages, this thing puts them both into one big reinforced crate, the green channel, for a single reliable delivery.
And the display on the other end knows how to open that crate. That's the elegant part of the engineering. It's a precise routing mechanism. And because it's passive, it's designed for zero failure.
And it still supports some serious resolutions.
Oh, yeah, up to 1600 by 1280. This isn't just about changing a plug shape. It's a critical timing solution.
And that kind of specific engineering, I guess, that explains the price. This device, it weighs only 1.8 ounces.
It's nothing.
It's less than 3 inches long, and it costs $410. It's just hard to square the size with the cost, if you're not in this world.
It's the difference between a consumer gadget and a mission-critical tool. Look at HDTV Supply's catalog. They sell basic component to VGA converters for maybe $25.
Right.
The tvONE sits in that high-end pro category because it offers precision and, importantly, compliance.
Compliance is key here. I saw it supports options like being TAA compliant.
Which, for listeners who don't know, means it meets the U.S. Trade Agreements Act. So it's approved for use in U.S. government, military, and institutional projects.
Where equipment sourcing rules are incredibly strict.
Exactly. This isn't about watching a movie. It's for medical imaging, defense simulation, control rooms, places where signal failure is just not an option. It's priced for its engineering and for that guarantee that the HV sync problem is solved cleanly.
So the big takeaway for you here is that the tvONE 400-291-001 is a very specialized passive tool. It's engineered for one job, managing signal timing between professional VGA and RGB standards.
And it really highlights a broader truth about how technology sticks around.
Which brings us to our final thought for you. When a piece of hardware this specialized, this expensive, is still necessary, what does that tell you? The persistence of these supposedly old standards like high-res VGA or BNC connectors, what does that say about the actual lifespan of tech in critical environments? And how does that need for legacy connections shape how people buy equipment today, decades after these things were first introduced?